Welcome to The Explainer. Today, we are diving into a new AI architecture called Fgsgr, and it's a big one. It tackles a really fundamental problem. Modern AI can see the world in incredible detail, but it still thinks in a straight line. This framework could be about to change all of that.
Okay, so at its heart, this whole thing is about seeing the world at different frequencies. Just look at this image. The low frequency, that's the big picture, the leopard's overall shape. The mid frequency, that's where you see the actual object's form. And the high frequency, that's all the super fine details, like the texture of the fur. It's about seeing the forest, the trees, and the leaves all at the same time.
And what's really cool is that this isn't just some neat trick for pictures. Nope, it's a universal principle for understanding pretty much any complex signal. In language, it's the difference between the main topic of a conversation, the sentences, and the specific words you choose. For brain signals, it could be what separates a long-term mood from a fleeting thought. It's everywhere.
So this big idea has a name, the Universal Signal Decomposition Framework, or USDF. And it's the core concept that lets an AI learn these multi-scale representations of, anything. This is the foundation for the entire Fgsgr architecture we're talking about today.
Okay, so if seeing the world in frequencies is so powerful, what's the big deal? Where's the problem? Well, the problem is that most AI today doesn't actually reason that way. It might be able to perceive the world in all these rich layers, but its actual thinking process is surprisingly, rigid. So on the left, you've got how current AI thinks. It's like following a recipe, one step, then the next, in a perfectly straight line. You've probably heard of it, chain of thought. But then on the right, that's us. That's human thinking. It's this dynamic, messy, incredible web of interconnected ideas. It's not a line, it's a web. And this table just lays it bare. Chain of thought is stuck in that single linear lane. It can't branch out to explore different paths at the same time. It can't synthesize ideas from parallel thoughts. And it definitely can't loop back to refine an idea. This points to a huge mismatch. Our knowledge is a web, but current AI is trying to get around it with just a single thread. And this is where Fgsgr comes in and changes the game. It's a breakthrough that lets an AI reason not in a straight line, but on a dynamic, interconnected graph, kind of like a human mind map. It finally solves that core problem by making the AI's reasoning process operate on the same web structure as its knowledge. So let's break that name down. The first part is self-graph reasoning. This means the AI literally builds its own map of understanding as it goes. It can add new concepts, forge new connections between them, and even change its mind by rewiring those connections as it gets new information. Now, the second part, frequency governance, is the real masterstroke. This is what tells the AI how to think on this graph, using different speeds for different kinds of thoughts. And this is where it all clicks into place. It takes that idea of frequencies from how it perceives the world and applies it directly to the act of reasoning. So, how do these two big ideas, self-graphed reasoning and frequency governance, actually work together? Well, think of it like a symphony orchestra. You've got different sections playing at different tempos, but they're all contributing to one big harmonious piece of music. Okay, this diagram might look a little intense, but the core idea is pretty straightforward. You've got these distinct layers, and each one processes information at a different frequency, a different speed. And the really crucial part is that information flows both ways. The tiny details from the bottom bubble up to inform the big picture, and the high-level strategy from the top flows down to guide what's happening on the ground. A great way to think about this is like a company. The slowest frequency, theta, that's your CEO, thinking about the long-term vision. The medium bands, alpha and beta, they're the managers coordinating their teams. And the fastest band, gamma, those are the frontline workers, reacting to things in real time and handling all the fine details. And here is the absolute killer feature of this whole thing. This architecture completely eliminates that mismatch we talked about. With Fgsgr, the AI's knowledge is the graph, and its reasoning process is just the act of operating on that very same graph. There's no clumsy translation step between knowing and thinking. They are one and the same. So because this framework is so fundamental, it unifies how an AI sees, knows, and thinks, it could unlock some capabilities that, honestly, sound like they're straight out of science fiction. For starters, you could create dynamic models of an individual person's brain. By capturing someone's unique neural signatures across all those different frequency bands, you could build a cognitive twin to simulate and maybe even predict how that specific person thinks and reacts.
Okay, so you've modeled a mind. Now you can model how that mind sees the outside world. This could be the engine for true augmented reality. Systems that don't just overlay images, but deeply understand the relationships between objects, the environment, and what you, the user, are trying to do. And then, of course, you give that perception a body. This architecture is just a perfect fit for robotics. It would let a robot blend that high-speed, reactive motor control with slower, more deliberate long-term planning. This could make them way more adaptable and capable in the real world. And finally, you put it all together, and it could build a complete understanding of its entire environment. This means understanding a video not as a bunch of frames, but as a coherent world with physics, with objects that continue to exist when you can't see them, and with long-range cause and effect, a true world model.
The researchers behind this are not pulling any punches. As they say right here, this isn't just a small improvement. They see it as a new paradigm, a fundamentally different way to build intelligent systems where perception, knowledge, and reasoning all work together on the same unified structure. And that leaves us with one last pretty mind-bending thought. If a single AI framework can model the world outside, a robot moving through it, and the human mind perceiving it, what does that tell us about the nature of intelligence itself? Thanks for joining this explainer.